this video, we'll look at the algebra topic of rationalizing a denominator, and we're going to specifically look at an example that is going to require using a conjugate pair. The first example, 8 over 1 minus the square root of 3, the problem when we want to rationalize the denominator is that we want to get the square root of 3 out of the denominator. It's okay to have a square root in the numerator when we're rationalizing, but rationalize the denominator means remove the square root from the denominator. You might also see a problem that says rationalize the numerator, and that would simply mean get rid of the radical in the numerator. Now, to get rid of this one, in other examples, simpler examples, when we had a square root of 3 in the denominator, so for example, this example, 2 over the square root of 3, we simplified that by simply multiplying by the 1 in the form of square root of 3 over square root of 3. We got 2 square root of 3 over the square root of 3 times 3, 9, which is just 3. So we'd get 2 square root of 3 over 3. The way we eliminated the radical in the denominator was we multiplied that square root of 3 times the square root of 3. And then to counter that and keep this expression equivalent, we multiplied the numerator by that same square root of 3. And that's how we rationalized when it was just a simple square root of 3. When we have something added or subtracted to that radical, for example, in this case, 1 minus that square root of 3, we have to use a little slightly different technique. And what we're going to use is a conjugate pair. This will hopefully look somewhat familiar because we just did a lot of work with factoring. And if you recall, when we factored a squared minus b squared, we got a plus b times a minus b. Well, a plus b and a minus b have a special name. They're called a conjugate pair. And let's look at what happens when we multiply a plus b and a minus b. If we use the FOIL method, first times first, a times a is a squared. Outside times outside, a times the opposite of b would be negative ab. Inside times inside, a times b is ab. And then last times last, b times the opposite of b minus b squared. When we do that multiplication, do you see that this AB minus AB is going to cancel out because AB minus itself, they just go away. So what we're left with is A squared minus B squared. So that is the tool we're going to use to get rid of the radical. And let me show you how it works. The conjugate for 1 minus square root of 3 is 1 plus the square root of 3. If I had a 1 plus the square root of 3, its conjugate would have been 1 minus the square root of 3. So we have the first and last term are the same, but we simply change the sign from subtract to add or add to subtract. So the conjugate to 1 minus the square root of 3 is going to be 1 plus the square root of 3. So I can see that what I want to do is multiply this denominator times 1 plus the square root of 3. I can't do that without also multiplying the numerator times 1 plus the square root of 3. Okay, now we've got our 1 plus the square root of 3 over 1 plus the square root of 3. This is just a big fancy 1. So I can multiply by that 1 without changing the value of our 8 over 1 minus the square root of 3. When I do that multiplication, in the numerator, I'm just going to distribute. So in the numerator, I'll have 8 times 1 plus 8 times the square root of 3. In the denominator, I'm going to need to FOIL. Well, you might have done enough of these examples already that you know it's going to come out to be 1 squared minus the square root of 3 squared, and the square root squared is how we're going to release that 3 from the radical, because the square root of 3 squared is just going to be a 3. But I'm going to go ahead and work it out. But let me say that eventually you want to get to where you just jump to the answer 1 squared minus 3 by having done enough examples. But let's not skip any steps here. When I distribute, I'd have 8 times 1 is 8. 8 times the square root of 3 is plus 8 square root of 3. So I have 8 plus 8 square root of 3 in the numerator. In the denominator, using FOIL, first times first is 1. Outside times outside is square root of 3. Inside times inside minus the square root of 3. Last times last minus the square root of 3 times 3. Do you see what happened here and why we eliminated the radical? Because this 3 square root of 3 minus the square root of 3 cancel each other out. And the square root of 3 times 3 is just going to be a 3. So now if I simplify this, what would it look like? 8 plus 8 square root of 3 over 1 minus square root of 3 times the square root of 3 times 3 is just 3. So now what I can see is that I have minus 2. So that's it, other than this will simplify. So let's see how this simplifies. Oh, you know, I'm recognizing now I may have jumped the gun when I multiplied the 8 times the 1 plus the square root of 3. When I distributed that, it wouldn't have hurt to have left it 8 times the quantity of 1 plus the square root of 3 until I got to this end step. That would have made it a little more clear what we're going to do, because what we want to do is reduce this 8 and negative 2. 8 divided by negative 2 is negative 4. Negative 2 divided by negative 2 is positive 1. Negative 2 divided by negative 2 is just 1, right? So I can see that when I distribute that negative 4, the final answer is going to be negative 4 minus 4 square root of 3. Or you could even leave it factored. Negative 4 times 1 plus the square root of 3. Either of those answers would have been okay. Let me make sure you see how we would get there, though. If we had, as we did, if you had already distributed it and it looked like this, the 8 plus 8 square root of 3, we can't just divide the 8 by the negative 2. We've got to divide both the 8 and the other 8 by negative 2. Negative 2 goes into negative 8, negative 4 times. Negative 2 goes into 8, negative 4 times. So we'd have negative 4 minus 4 square root of 3. Any way you look at it, that's what we'd get. Either of these two answers are equivalent. Let's try one more example. Do you see what the conjugate is for this example? What is it that I'm going to multiply it by? I'm going to multiply it by square root of 14 minus the square root of 13. Because I want that to pair up with the square root of 14 plus the square root of 13. And so I'm going to do that to the numerator also. And when I FOIL each of these out, when I FOIL the numerator and the denominator, here's what it would look like. The square root of 14 times the square root of 14 is going to be 14. Outside times outside, negative square root of 14 times 13. I'll pull out a calculator later to do that if needed, right? inside times inside. So it looks like we're repeating that. It doesn't eliminate, it repeats in the top because these weren't conjugates, right? It's a minus and a minus, so it's not going to cancel out. And then last times last, minus the square root of 13 times the square root of 13 is just a 13. Square root of 13 times 13 is 13. I could simplify this 14 minus 13 is going to be a 1, and I could simplify this, the two similar, like radicals, but I'll save that for just a minute. I'm going to use the shortcut here. I'm not going to FOIL it out. If you need to, go ahead and FOIL it. First times first, outside, outside, inside, inside, last, last. When you do that, you'll see that the outside and outside, square root of 14 times negative square root of 13 is going to give us the opposite of square root of 14 times 13. And the inside times inside is going to give us positive plus square root of 14 times 13. So those are just going to cancel each other out. What am I left with? A squared, so the square root of 14 squared. So the square root and square just undo each other, so I'm left with a 14 minus b squared, the square root of 13 squared, the square and the square root undo each other, so we're going to be left in the denominator with a 14 minus 13, which is just 1. So let's continue simplifying here. 14 minus 13 is 1, and then minus 2 times the square root. If I multiply, that's 14 times 13, I'd get 182. And then in the denominator, it's just a 1. So I don't even need to write that. And it looks like that is all that we need to do. Oh, I do see one small mistake. I'm sorry for this. Do you see that? I'm looking at the sinking. Every time I do a problem, as I go along, I check before I say that I've got the final answer. It's okay to make small mistakes along the way. I apologize that I did that in the video. But in this negative square root of 13 times the negative square root of 13, did you already catch that? Maybe you saw that and thought, wait, I thought that should be positive, and you're right, it should be positive. Because this negative, last times last, negative square root of 13 times negative square root of 13 would be positive square root of 13 squared. So it would have been positive 13. So in the numerator, we'd have 14 plus 13, not 1, but 27. I hope that didn't throw you off too much. If it does, let me know, and I'll help you process through that a little more. But what we should get for the final answer is 27 minus 2 square root of 182. Don't be confused with how that affects the denominator, because in the denominator we do still have minus here. So it does still come to a 1. Well, I hope that this example, or these two examples of rationalizing denominators using conjugates, has helped you. If you do need further assistance with rationalizing denominators, there is another video, Rationalizing Denominators, where we don't have to use a conjugate, but some of those examples are working with radicals that have a index other than 2, so not a square root, but third root and a fifth root, etc. So watch for those other 2 videos if you'd like more help with rationalizing other types of denominators.